Alright, kicking things off with 100 Days of ML, day 76. And I'm continuing to read Paper a Week. So things are moving pretty slowly, like this week, just because my finals are coming up. In fact, my first final is tomorrow, linear algebra, which is going to be pretty interesting. So the paper I'm reading today is a continuation of the past few days. Statistical Modeling, The Two Cultures by Leo Bremen. It's a very interesting paper in the sense that it gives a pretty good understanding of like how data preprocessing should be accomplished for machine learning. And unlike the previous paper, which was tidy data, this one talks more about like, comparing the process of iterating a model and the process of iterating your like focus on fitting the data set instead of improving the model architecture, which is actually a pretty important, I guess, discussion in machine learning today, because you could focus on the model without really paying attention to what the data set is. However, it's not going to be the most optimal solution to that problem, because if you don't really understand what the important features are, or how to efficiently fit that data set, you're just going to focus yourself on improving the model, and it's not going to be that efficient. It's the same thing that when it was went over in ML applications, the book. The first things that they recommend is to take a simple model, and then iterate on that model as you go through your application. So I'll be starting off with section 6, which is the limitations of data models. And I'll try to finish section 6 and 7 today. All right. So what I'll do is I'll mute myself when I'm reading and taking notes. And then once I'm done, I'll unmute and provide a summary of what the section's about. Okay, so this section talks about, I guess, the recent progress in like data models. Well, not really progress, but more talks about the trend that has erupted in data models, where, like, in the past like few past century, the amount of data collected has become like incredibly high. So now these old data models like regression and logistic regression and all those like linear regression type models can't really fit these multivariate, highly complex data sets. Now, there are other algorithms like SVM and stuff that reduce dimensionality, but even then, it's hard to, I guess, understand what exactly SVM is doing, even though it's not a complete black box. But what the author is trying to convey is the fact that, most statisticians try to decode the problem first by analyzing the data set. But in today's world, that data set becomes incredibly hard to analyze, mostly because of the fact that, it may contain hundreds and thousands, maybe upwards to millions of elements, and also hundreds of thousands of independent columns, which may play a factor in determining the predictive or classification of a specific task. So now, when you have such a huge amount of data incoming and being stored, how exactly do you analyze it? And I guess the author is trying to say that, all of these statisticians have ruled themselves out of the most interesting challenge in statistical problems that have arisen today. Because that just basically means that, they're not really focusing themselves on developing ML models or deep learning models. They're kind of just analyzing the data sets and stuff. And these problems are now being solved by like non-scientific, non-statistical statisticians, because of the fact that they're just using these concepts of ML in any sort of problem that seems fit. And something that I have to mention that was the data and the problem guide the solution. To solve a wider range of data problems, a larger set of tools is needed. It's a pretty nice quote because you have to adapt the tools you have to the problem that you're tackling. Because if you're taking a small screwdriver and like a small hammer and you're going to try to break down a mountain, it's not going to work. You're definitely going to need something like explosives or, some sort of big tools. However, if you bring explosives and, a truck and a bulldozer to like trying to split a rock or something, definitely not appropriate. So your tools definitely have to adapt based on the task at hand. All right, let's continue with section 7. All right, let's finish up chapter 7 review. Well, not chapter, section 7. All right, so it talks about algorithmic modeling, which is kind of encompasses the machine learning community. And so basically, it's the when he talks about algorithmic modeling, he's talking about the transition where in this early to well, late 19th century, around like 1960s, 1970s, and upwards, a lot of people, specifically computer scientists, are focusing on these very hard, difficult tasks which couldn't be solved by normal data models. And by a combination of these computer scientists, social scientists, and some sprinkled statisticians, they were able to develop a new form to tackling these algorithmic these problems at hand. So the community consisted of young computer scientists, physicists, engineers, and a few aging statisticians. So it went from the transition of, mostly statisticians focusing on their data sets and the way they bring up the function to solve this relationship between the data set and the real world, to these computer scientists just coming up with any sort of black box that can model or fit the nature of the world without any importance to how it does it, as long as the accuracy of like it fitting to the real world is high enough. So they start tackling tasks like speech recognition, image recognition, nonlinear time series prediction, handwriting recognition, and financial markets. All of these areas where it's not very simple to solve. I mean, most of these areas produce very complex multivariate data sets, which cannot be decoded by a human. Maybe by a human, but by a machine, it's very nonlinear to really think through the problem. And so they treated the problem as a black box, where the inside was completely complex and mysterious, and it didn't really matter to them as long as the model produced accurate data. And by doing this shift in thinking, from instead of just focusing on the model and trying to fit the model, they were able to come up with a lot of interesting new discoveries. And one of them is like SVM, support vector machines, which have done a great amount of work in the past few years. And more optimizations for these algorithms are coming out. And it's a very new, all of this has been happening in the past decade, and especially in the past 5 years, machine learning has been taking off on a very, very high growth rate. So yeah, there's been a lot of development in the past 5 years, specifically with ML. And he talks about 3 lessons which are really important: the multiplicity of good models, conflict between simplicity and accuracy, and dimensionality, curse or blessing. So that would be the next few sections, but I'm going to wrap it up today with section 7. I'm going very slow for the past few days, but it's understandable because I have my finals coming up, and I do have to do well on them. Day 77. Section 8, which is all right. With that, I'm gonna conclude for today.